just so you know what the subject matter is. I'll click over. Not to worry about this. Okay, we're going to try to cover continuation of multiplexing, controller area, network CAN, and all that stuff. And I'll put my little picture in there just in case you want to see some movement in here. But basically, it's a continuation. When I decided to put this multiplex together in CAN, I didn't realize how in-depth of a subject it can be. But I'm also trying to make sure that when we get into it, I know it's in parts because 1 hour is a lot to try to accomplish in 1 hour. It ain't never going to happen. But we are going to keep continuing it on it. So, but there's no sense in jumping into something totally complicated unless you have the base information. And again, in the real world, I'll be very honest with you. I know we're going to go through some more. Hopefully you saw part 1, okay? I know everybody talks about, you know, testing, and in this part here, hopefully I'll show you some slides with tons of wires and stuff, but I'll be very honest with you, a lot of that is judgment calls too. So if you get a code, for example, a sensor, I don't care if it's for emissions or whatever the case may be, I have found, and it's not 100%, but a lot of times when I retrieve the codes and it's related to a sensor or something like that, if that sensor is reasonably cost, to be honest with you, if it's like a $70 sensor, I'm going to pop that $70 sensor in, and most of the customers get that, because if it gives me a positive result for $70, little minor labor and stuff, versus if all of a sudden I overcomplicate it and I start getting into the CAN wiring and everything else only to go find out it's a sensor, you know what I'm talking about, just doesn't make sense. But again, for $70, if it's not sensor, guess what? Now your work begins, okay? And in CAN and heavy duty trucks, it's a whole different ball game. I mean, we have so many aftermarket stuff that gets put onto these vehicles. Even stupid stuff. I work on some Amazon vehicles with the Pi wagons. They're heavy with CAN, with the cameras, 360 cameras and stuff, with the interfaces, with the instrument panels showing you. I mean, go figure. These guys still get into issues and scrape those trucks. Just kidding. I'm not trying to get into that conversation, but even those we've navigated into where you have to get, use jump drives to make some firmware, and software changes. So it's a whole new world. So let's see what kind of trouble we can get into here. Again, we get the part 1 PDF in this chat. Doreen will have to answer that question. I'm not sure about that. But before we get started, let's do a little quick review from Multiplex, speaking of part 1, and that's the reason I did a couple slides with the review. Benefits of using multiplexing: reduced wiring, multiple controllers can be utilized over bus, which the whole concept is, let's simplify the communication, coupled with controller area network CAN, higher multiple speeds of communication is available. So, but at the same time, another benefit of it is that in many cases, relay circuit breakers, they're replaced with electronic devices. The multiplex system continuously monitors inputs and sends messages over a shared wire data bus to control outputs. And Jim, you're a perfect example. I'm not trying to say that you're oh yeah, I see that reduced wiring. I'm going to get into that. I am so glad you put that. There's a couple of slides going to get into that, actually. You're absolutely right. You beat me to a punch here a little bit, But anyway, a multiplex system can interpret different messages transmitted on the same wire data bus. The data bus handles multiple messages same time. So multiple control modules communicate with each other Typical data bus consists of a twisted pair of wires carry message. Look, I laugh because I'm trying to watch the chat box too, and sometimes it's hard for me to watch it, and for some odd reason, and today I'm not getting the chat box to come up as full. So if I miss answering you guys or something, please forgive me. I'm not trying to ignore you. It's just I'm trying to multitask. So, but that's why I laughed. Somebody did that reply with a ha 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 with the wires. Most vehicles adopted the CAN, let me get myself out of there. Adopted the CAN as the preferred data bus system. CAN is a serial data transmission network used for ECM networking, mobile, onboard, external, and so on. So major advantage is that should one of the modules fail, and again, I'm talking about in the perfect world, okay, the remaining modules will still be able to communicate. And CAN 2 is the basis for J1939, high speed, and I'll have it in a couple of more slides coming up towards the end. And again, J1939, that's a newer version, newer as far as, within quite a few years, the heavy duty vehicles, not to mention construction and off-road use that, So, but it's a kind of a flexible, it allows for speeds as low as 10 gigabits per second, so on, so. Now, for the person that laughed, this just, where was I? I know, I had to get, this is a garbage packer, if you guys don't know what it is, Peterbilt garbage truck, and what happens is you have a right hand and left hand steering, so naturally you also have, all the gauges and switches, everything that goes along with it, okay? And I couldn't help but, putting the pictures together. I went to somebody's facility, I happened to walk in at the right time, and Modern Disposal, and there are one of our bigger garbage haulers, waste haulers, and one of the guys that's gone through some of my classes stuff, he says, hey, as long as you're here, check this out. So he was in the middle of this job, okay, and he had the dash apart, so I snagged some pictures, and speaking of reduced wirings, okay, but now, all of a sudden, last month we talked about, the twisted wires and so on. So here you got a mess of wires, and I guess I was trying to be facetious, pick out the, multiplex system wires, and we talked about the twisted wires. But, the reason he was over there, okay, the circuit board was buried under that harness and wire, okay, and it's burnt, guys. And actually, I have it in my hand here, all right? And we'll zoom in over here just so you can see, all right? Oops. Let me go live again. Sorry. If you can zoom in on here, okay, just zoom in, okay, just to give you an idea. This is a typical circuit board, and I'm not quite sure what you can see, but on the sides over here, you will see designations for the plugs over here. Like over here, it's for the engine, okay, chassis 2, okay, then you got switch, then you got transmission, cab 1, and so on and so on, okay? So you have a lot of potential here for issues, okay? Then of course on the flip side, there it is. I don't know, I'm not good enough to take one of these boards and actually fix it. I'm not about to, but I'll switch over again for a second. I'll switch over to the slide, okay? So I left off what happened. I don't wish this on anybody. Basically, washer dropped onto the board and shorted and burned the circuit board. And it's like, don't ask me how, where, how. I'm sure there's a backstory to this, but I'm hoping I'm not, I would never be the guy that actually, was responsible for something like that. So, but J1939, again, a little bit of review. It's SAE standard. It's a communication network, basically says a high-speed ISO, 1189 CAN-based communication network, supports real-time closed-loop control. And again, you have it in your handout, so I don't want to spend too much time on the review, but I do understand there are some people that didn't see part one, you know. And basically, just keep it stupidly simple. Think about a typical truck and a number of major manufacturers and their components. Look, you got different truck manufacturers, different engine manufacturers, different transmission manufacturers, different ABS manufacturers, different other component manufacturers. The problem, it's not real problem, is however they do need to communicate with each other, okay? And just a little note again, I'll remind you again, your scan tool becomes another part of this communication network. The minute you hook up to this system, this test tool, call it whatever you're happy with, will appear as another controller in the vehicle's network. Basically, it has to have access to all the data that the other controllers can access. So, you know, and I put this over here, if you can see over here, just to give you an idea, I put a pictorial. Now, if you look on here, you see the tractor-trailer bridge. That particular system over here uses what they call a PLC, a power line carrier. The PLC basically enables communication take place on a non-dedicated communication wires, and it's been around a while. In this case, those of you that work on trailers and stuff too, it's your blue wire, you know, out of your 7-way plug connector. Okay? And primarily it's used for ABS, okay? And basically what it does, it's a technology that converts a communication signal to a radio frequency signal, and then it superimposes it over, say, the 12-volt auxiliary power wire, which I mentioned was the blue wire. You got a transducer that converts the radio frequency signal back to a signal that the receiver module can use. Okay. Originally, of course, they were in the older systems. I shouldn't say older, still see them around. Used with the J1587, J1708. You guys will probably be comfortable with the J1708. Those were the 6-way plugs, you know, data bus protocols. But however, since your newer vehicles, let's put it this way, quite a few decades ago, you know, we're into that I'm having a little issue here that you guys can't see, and I'm trying to correct here, you know, so. But let me go back, J1939 protocols, sorry about that, okay? So, what we're basically doing here, if you're looking at, we're going to get into these electronic service tools. In that previous page, you saw kind of a VCI interface over there, and we're going to get into that area. I figure instead of putting the cart before the horse, let's talk about the stuff that we do. You know, we have to get into these systems, okay? So I'm not quite sure how much everybody knows about scan tools, and don't get me wrong, everybody has their own favorite scan tools, and there's tons of them out there, you know. So some people call it an electronic service tool, whatever. I'm comfortable calling it a scan tool, you know. But what are you asking for the scan tool to do? You're asking to view system identification data, which basically comes up on most of your scan tools. Of course, all day long, you want active codes, history codes. You want to erase clear inactive history codes. You want to view data. For example, perform bidirectional snapshot whenever it's possible. Okay. Reprogram customer if you're into it, and don't forget there's always you always have the I don't want to say cheaper, but if you're happy enough just to get in there to get some certain stuff, they have those type of scan tools out there too, you know. So here's a typical tester. It's connected to a device, and most of your better, more complicated ones that offer you a lot, they're going to have the vehicle communication interface, the VCI. Okay? It acts as a converter between the external interface of the tester and the diagnostic link connector. An example of the external interface of the tester is a USB connector, and you see it on the arrow over there. Okay, and basically it's the connection to your, say, laptop or whatever, you know. And it doesn't have to be a USB. It could be Bluetooth, Ethernet, or Wi-Fi, okay. And the green one is the one that I use. This is from a J-Pro. I get into the truck, tractor, whatever the case may be. And of course, there's special ABS VCI over there, and basically it functions the same way, okay. Now, you don't necessarily have to have a VCI. In this particular case over here, what you're looking, this is, I believe, my can-do. Okay, so if both the tester and control unit support, and I can't remember, I think it's a 100 base TX Ethernet, the VCI could be replaced by cable using a serial data port, you know. And that's nice too. If you notice in that box over there, all the different cables hooked to the same 16-pin connector, and that does show you how standardized everything is, you know. And the 16-pin is wired accordingly to receive the same information regardless. So if you got the 16-pin J1962, you know, connector, or the 9-pin, basically the assignments, okay, you're going to wind up being the same. Battery plus, battery power, can low, can high, and in case of heavy duty, it will be referred to as J1939 plus, J1939 minus, power and negative. Or you could also have the J1708 power, J7008 ground, and of course, don't forget the can shield. So here's an example of a wireless one. Okay. Typical physical layer, what we use on our heavy duty stuff, you know, it really is a kind of an open system connection, okay. The 1708, that was the original truck data backbone, and I already mentioned used the 6-pin, okay. And you have another standard J1587 that covers the communication protocols, okay. And it basically covers all the hardware, you know. But most of today's vehicles tend to be the typical heavy-duty J1939 9-pin connector. However, because heavy-duty trucks need to also meet OBD requirements, I think I went through that when I did the OBD stuff, okay. Some manufacturers also use a J1962, the 16-pin that you guys are used to with automotive, okay. Now, the nice part with this VCIs, they do utilize what's called an application program interface, API. And basically, the reason you're using the VCI, the API contains the procedure commands for initializing the connection. Remember, you're becoming part of that bus. Plus also perform diagnostic communication both directions and terminate the connections, okay? The benefit of this, to be honest with you, is the VCIs from different suppliers can be connected to any tester tool that supports the same standardized API, okay? So again, that's nice, isn't it? Connecting the service tool, okay? In that previous slide, let me go back over here. That I don't have in there is another area, and we're not tackling that here right now, is reprogramming, okay? The manufacturers of road vehicles with OBD are mandated to enable the aftermarket to reprogram emissions-related control units. That's a nice benefit of mandated OBD, regardless of the vehicle manufacturer brand. So you have another standard, okay, SAE J2534, that's the recommended practice for pass-through vehicle programming. Okay? So in this particular case, the VCI hardware device is referred to as a pass-through device, and it has a built-in combination of hardware and firmware as a pass-through interface. Okay, so again, the VCI plays a very, very important role. Okay? Now, connecting the service tool and so on and so on. Okay, each each OEM produces its own diagnostic calibration software, okay? Because you're looking over here trying to read fault codes, monitor parameters. Some of these are available with your scan tool, and some are a standalone that can be purchased for your scan tool. So I'll give you some examples, okay? Allison Calibration Configuration Tool, ACCT. Allison also has a Diagnostic Optimized Connection, DOC. Then, of course, Bendix, your ACOM. Freightliner's got a Service Link and Easy Wiring. Meritor, ABS, of course, and other stuff besides ABS in it, has their toolbox software, Navistar Master Diagnostics, and so on. And don't forget, of course, Cummins Insight. So we have a lot of options here that can help us. Now, real fast, because this was, I believe I had that in my OBD, but here's a data connector. That's your old 6-pin, okay? And I already referenced the 1708, okay? And again, it basically does the same thing as 1939, okay? And what are you trying to do? Various communication protocols are used in transmitting data. The 1708 was common protocol in the 90s and right up to the early 2000s. But the whole thing is, it's all about speed, you know? So because of speed, we went into this, okay? The J1939. And we went through a little bit of a transition, I should say, on this too. J1939, black 9-pin, and of course then we went into the green 9-pin, okay? And the whole idea here is that the only thing, if you work on Macs and Vols and stuff, don't forget, you got a 16-pin. Okay, they opted to go for that, and I think in the last one, just like here, okay, I made sure everybody understood that if you have a Volvo Mac and if you got the 16-pin, you'll probably get more stuff out of it than you would on your 9-pin. Okay, here's your 1939 again. If you didn't see some of the other lunch and learns, you'll have it in your handout if you've never tried to see what your connections are. And like I said, you got the 39 bus plus dominant high, 39 bus, you know, ground, negative call, whatever you want, right? Can shield, and of course, because you still have older vehicles out there that you're trying to connect to, you got the other ones too, right? And again, a little note on there in case you missed it in the other lunch and learn, you know, the 2013 green color 9-pin is backwards compatible with the pre-one. So, you know, and you see a little bit of a, like a nibble or possibility, whatever you want to call it. It's a little bit smaller. It's got a little kind of a block on the side designed to block access by a black pre-2013, okay? So 2017 saw the introduction of multiple CAN channels, compensate for increase of sensors, ECUs. Okay? And these are just examples. One CAN for powertrain, another CAN for everything else, such as radios, body controllers, you know. And again, CAN 1, typically for powertrain. 2016 Peterbilt, Kenworth, Volvo moved to the powertrain traffic to CAN 3, okay, and that is why the normal 9-pin connectors would not work. One way to overcome this, you could go out there, purchase a CAN 3, do CAN 1 crossover, you know, or update your cables. Okay? Now, this is the one I told you, which plug should I use? And again, Mac and Volvo are using the 16-pin, and I run across that. You know, I'm so. If I suspect more of an engine problem and stuff, I'm so, you know, got out of the habit to reach for the 9-pin. I see a Volvo Mac brand, I go right for my 16-pin adapter and go right in there, okay? And again, I told you, you know, unfortunately, 9-pin doesn't always read the entire vehicle, may only provide diagnostic information from the drivetrain, you know. So, you know. So scan tool quick takeaways, okay? What to call an electronic tester? I told you I'm comfortable. You know, it takes a lot of research to put this stuff together. So every time I read, everybody that puts out books and stuff out there, they'll have fancy names for it. Some will call it electronic tester, TST and stuff. To be honest with you, I come from the automotive. I do automotive all the time too, besides trucks. I'll just call it a scan tool. Okay, and again, reminder, when you hook up a scan tool, it becomes part of the network for communication occur. The partners, I'm talking about the scan tool and control unit, they have to adhere to the same communication rules, and we call those protocols. Okay, scan tool sends a message request, and I'm going to get a little bit more into that once we get actually into looking at the modules, nodes, whatever you're comfortable with, to a specific controller or to a group of controllers, receive an answer. So we don't get confused, okay, you might run across the following terms. All right? Onboard diagnostics. If I want to describe it, I would say it's a vehicle and ECU self-diagnostics, monitoring, and so on. On board. Off board, that's us guys, okay? We hook something up, that's us troubleshooting. Onboard communication now, this is communication internally within the system. It's an ECU to ECU, controller, node to node, whatever, you know, makes you happy, communication over the in-vehicle network. And of course, off-board communication, scan tool to ECU request and ECU to scan tool response, communication following the diagnostic protocol. So I wanted to set the stage here. Now this here, okay, I do a lot of work for a Metro Transit people. All their guys come, they have to come through the brake course. I've been doing it for the last 20 years, so I have access to a lot of their stuff over here. Okay? So this particular picture that you see here is we inherited in my area quite a few electric buses, okay? And this is from a new Flyer electric bus. And basically what you're looking is you see a series of multiplex modules with access, with easy access, I guess, communication ports. When you see these number ports, you know it is definitely going to be complicated, okay? So this particular here, if you see the, let me see if I can get up here. You see this 1, 2, 3, okay? These are used for multiplexing. They use what they call the vehicle multiplexing module system. Okay, the particular ones I just showed you here, again, these here, okay, they're what they call the VMM, and I believe the number was 1615. I can't remember everything. Okay, they're basically considered general purpose electronic controller. And just to show you the complexity of it, you know, this does have 16 inputs, 15 outputs. I'm not going to name them all, you know, as well as 2 CAN J1939 communication ports. If I remember correctly, 7 digital inputs are used for reading active high-low signals. 1 is used for reading active high signals. 1 is used for high power, you know. It also has 8 inputs capable of reading analog voltages, 1 DC coupled frequency input. It also has an example, 12 high side outputs with a maximum pulse width modulation frequency of 500 hertz, 4 which are capable of current sensing and more outputs. So current sensing, you know, read, correct, and all that stuff, you know. Do we have a problem? You know, it's all done in the modules, okay? And you will notice there are 4 color-coded connections. Okay. And let's see if I can get that in over here. Oops, shit. Excuse my French. Why am I having problems? Uh-oh. All right, back to it. Sorry about that, guys. You know, button knowledge, my little thing isn't. I've had a very, very bad week here. My shoulder's all screwed up, so I'm trying to overcome that. But anyway, what happens, it is a plug and play unit. Let me get back to that picture here. It is a plug and play unit, and there are 4 color coded connections, you know, so being plug and play, that means you can program it and so on and so on. But what you don't see in this picture, there's also a CAN repeater. I think last month I talked about, you know, stay within a certain length of your cables and wiring, okay? Just think about how big a bus is, okay? So this actually acts as a new starting point, you know, gives you the opportunity to extend the length of it. So now this is where I was heading for. This is basically when we were on, okay? Don't be sorry, I'm looking at chat box, for joining late. You know, it's okay. My whole world is late. So I'm just kidding, James. You know, thank you for coming on. But if you notice, this over here is basically just a start. Okay. The nice thing about it is at least you drop down that panel that you saw in the previous picture. Okay. You guys see that panel down there? Okay. And this is what you basically have on there. At a minimum, it gives you a chance to try to start some diagnostics. But I'll be very honest with you, with this particular bus, the wiring, there's about roughly, I believe, 110, 115 wiring pages of wiring diagrams. And in the beginning, when we first came on, we had a little bit of a humor laugh about reduced wires, and this is a perfect example, okay? Now, the nice thing, of course, is, you know, when you do get in a wiregram, and I just kind of picked that out a little bit, we need to really get comfortable with wiring diagrams, you know. But if you see over here, you do have the CAN. I hate to hit my my clicker here, you know. I'm gonna try so I don't lose it. Yeah, if you see over here, you got CAN high, CAN low, and so on. You got the shield and everything. And the whole idea of what we're trying, you've got terminating resistors here. The whole idea of what we try to do in these multiplex series is to get you comfortable, so when you do get into your wire diagram, at least you know what you're trying to look for, okay? So, and when you have your hand out, I put on there, just try to pick up the end of the line resistors, CAN high, you know, get comfortable with doing that kind of stuff. Okay? And this is another picture over here, you know, showing you, most of them will give you a legend. What do you have going on? And like I said, it's just no different than a road map. You get into a legend, you try to figure out what's going on. So here's another one. I'm going to get into topology. You know, why would you care? So what is topology? Okay. And if you were to look it up, you'd probably come up with that it's an organized structural system that remains unaffected when subjected to a sequence of events. Okay? And this leads me, to be honest with you, to a good point. Any book or information system you use, and that I just read you a definition, go into the definitions. Sometimes you might learn more from definitions than the contents. At a minimum, it will help you better understand the content. Basically, the term topology is used in serial multiplexing, which you got the picture over here, to indicate that no single controller network to the bus has more priority than another. You know, and I'm not into this other area. I see a lot of trying to think how far I should go. I'm not going to get into LIN local interconnect networks, okay? They're an example, another series type of network, okay? The LIN uses a master slave and vehicle networks used for interconnection mechatronics devices, basically sensors and actuators. And it's also used to control units that get along with data rates that are not higher than 20 gigabits, you know. I guess the typical application I could come up with is, if you got doors or seats and possibly some air conditioning system portions of it, And Lin does make it a good supplement to a CAN bus if the bandwidth is not required. So, in automotive, you might start seeing also a flex ray network, and that would be similar, this daisy chain, okay? I just see Mike. Mike, thanks for being on. I know on my can do, I think it does get into industrial type of stuff, but if I'm not mistaken, it's more product specific. But that's a good question, No, and I know you get quite a bit into the construction, and we've been back and forth, a few times online, because I remember you asking a question about CAT and everything. So, but that's a good question. Maybe somebody else can actually, if they get into that area, answer it. Now, here's a series loop. Okay, they're connected in a line. Okay? Like the series straight line, I just, you bend them over, you connect them together, and of course out of there you can also connect your DLC to, into the loop. In this configuration, a generated mesh is sent out in both directions. Each module, call it a node, again, everybody calls it different, receives the generated message from both directions at the same time. This type of network is often used in conjunction with other networks, parallel star. And that's the thing, once you get into these systems, you're going to find it's a mixed match of systems out there, Again, looking at the picture, it's got no central point, For testing, each module must be disconnected, find a circuit or module fault, Now, this is a star network, okay? In this type, the individual legs project out from the central junction, connection, call it whatever you're happy with. In these type of systems, you might want to isolate the legs from each, section, okay? And if you look at this picture, you can actually visualize that if there's an open in a leg, the module, node, whatever you're happy with, I got the N on there, on that leg will no longer be able to communicate, which makes all the sense in the world. I mean, hey, guess what? It's plucked out of there. You got an open. Short circuits to power or ground can take down the whole network usually. However, in this type of network, the only effects you're going to wind are the open circuit faults. So again, you're going to have to get savvy with what's out there. But I'll be honest with you, the most common one, okay, preferred method of networking by most manufacturers is what you're looking at over here. Each module node has its own leg stub from a central bus. You will also find that most networks will have one or more of these parallel sections. And it's easier to isolate the modules for testing. And like I said, the thing is, I'm kind of on a on a time restraint, so we could spend hours on just this stuff. So, but again, it's a start point. Then the other one, of course, is junction connected to star parallel style. Again, easy ones to diagnose. So a module can go offline and the other's still going to stay online. Basically, a little bit of a tip here, isolate and use jumper wires, connect the leg off the offline module to the DLC, and that'll eliminate the wires if you suspect an open, short, or high resistance, okay? And each leg can be directly tested to find a fault, and in case I use the same chassis over here, cabin, just so you know, very popular signal acquisition modules, if you ever run across it. They're part of CAN, and they basically act similar to a router, a communication network. Now we're gonna continue a little bit more with topology. Okay, chances are pretty good that most vehicles will have a combination of networks. I mentioned that. You'll also run across different types of junctions, connectors, star point style or comb or cap style. Very popular with cars to connect all the circuits. Circuits to circuit style using blade or similar connections. knowing the connection locations, what type style can simplify the testing of the module. So again, it's a learning curve, excuse me. Unfortunately, looking at a diagram doesn't always let you know the type of connection you're looking for, you know. Don't forget, what about optional add-on modules? Big time in our trucking, you know, between the ELDs, and everybody wants to see, you know, where the driver is going, want a lot of information, inboard, outboard cameras, and I mean, it just goes on and on and on, okay? So it's possible for Scan Tool to show that optional module is a non-communication issue. What about an aftermarket module? And that's what I was basically talking about, that you're not going to wind up on a diagram affecting these. You know, I mentioned all the add-ons that a fleet decides to add on. And I'll be honest with you, I've gotten into situations where I just couldn't figure something out. You know, tried to get in there to get information with my scan tool, and finally I get to a point I just disconnected those things and just go right down to the very first connection that originally was there. Bingo, I'm back in there. So that tells me some of these manufacturers aren't really, I'm not sure if they know what they're doing. Okay? So this picture here, okay, shows you, you know, because we're in a discussion, high-speed CAN and low-speed, okay. You have two of them, you know. The high-speed CAN has a nominal data rate, maximum 1 megabits. Okay? Low-speed, of course, 125. You know, there's a reminder again, even though high-speed CAN is specified for a data rate of 1 million bits, okay, mega, in practice only 500 gigabits are used. Main difference, however, between high-speed CAN, low-speed, are the voltage levels and bus termination. And this is what I'm trying to show, you know, on a high-speed. If you see over here, you got node 1, node 2, node 3, call it controller, module, whatever, and you see the terminating resistors at the end over here. Okay, this basically is used by pretty near anything in automotive applications today, you know, and it does serve as a basis for protocols such as OBD. I mentioned automotive. We've talked about J1939 and CAN open. Okay, now there is a second generation of CAN, and it's referred to as CAN FT. And they call it CAN with flexible data rate. You know, so I'm not going to get into it in here, but, you know, again, but here, you know, if you were looking at a wiring diagram, don't always expect a terminating resistor at the end of it. Right? Here's an example, low speed connection. Right? If you notice, the terminating resistors are connected between the stubs and transceiver inside the controller, okay? And the low speed, again, the nice thing is these bit rates, they're someplace from, I think it's 40 gigabits to 125 gigabits. The nice thing about this low CAN is it allows CAN communication continue even if there's a fault on one of the two wires. And again, it's supposed to, let's put it this way, okay? And that's why you might also hear it referred to as a fault-tolerant CAN, okay? And in this system, the node has its own termination. So let's do this. So we keep talking about, very good, Ron, you're ahead of me already. Damn it. You know, just kidding, you know. Allison likes to use the NTCM terminators. Now, if in the real world, someplace along the line, we might have to check them. So here I put this together real fast, checking testing for terminating resistors. Missing terminating resistor will result higher resistance. What happens if an additional terminating resistor is added? This can occur due to the installation again. We're back to the aftermarket controller on the bus, and that controller has an integral resistor. Easiest way, regardless, to test for the above is using a multimeter in the ohm setting mode. Make sure the bus is powered down, of course. You're using ohms, aren't you? Right, the ignition is off, and both terminating resistors are in place. Okay? So here I put this together, use my fluke, okay? And I gave you some parameters, you know, testing for terminating resistors and a bus test. 60 ohms good, 120 ohms, one terminating resistor missing, 0 short between can high, can low, 40 ohms, additional resistor, you know, has been added. And of course, open circuit. Okay. So I'm going to shut this off for a second here. I'm going to go on here. And that picture, I had a little bit of a, I was trying to figure out how to configure this. I'll come back. So what I did so I wouldn't be jerking around trying to get my 60 ohm, because after all, we're using that a baseline. So it was easy enough. I have all the different cables and everything else. I can hook up, play what I want, okay? And I actually used the gate box. So it was fairly easy, you know. I just flipped the switches here, you know, 40, 20, and there's my 60 ohms, you know. So I just wanted to let you know, if I think I mentioned this in my one of my electrical diagnostic lunch and learns, but they're not expensive. But here's another thing, you know, so if you suspect something like that, you get rid of the terminating resistor and put this in its place. At least you'll know, are my wires working? You know, am I having issues with wires or whatever? You know, try to keep it simple. Back to this again. So let's go a little bit deeper. Bus access arbitration, you know, beginning transmission of a message. The first thing the controller checks to see is if the bus is available, also referred to as a carrier sense. I can put this on. If more than one controller node starts sending message, collision is going to occur. Arbitration solves the collision. The following will help understanding arbitration. You have it in your handouts, okay? The can differentiate between dominant recessive bits. And I'll be very honest, if you guys are like me, I have to read stuff over and over and over and over again just to make my old pea brain try to make it sink in. So I try to put enough, and it might look at first like it's kind of confusing. I got one section here, one section there, but you almost want to go back and forth, and before you know it, that bingo happens, that bingo moment happens, okay? So again, logical 1 is equal to recessive bit, logical 0 is equal to dominant bit. Can bus in the recessive state, and you might hear that. Logic is logical 1 if all the connected transceivers send a receiver bit. And I'll show you in a minute why I'm going through this. If one transceivers send a dominant bit, logical 0, it overwrites the recessive state of bus. And again, it's one of those things that you want to go over and over again. Every CAN message starts with a start bit, logical 0. Again, the dominant 0 overwrites the recessive 1. And all I'm trying to do is like, how do these nodes, modules, whatever, know, hey, I want to see you, I want to acknowledge you, screw you, I don't want to use you. That's how they do it, okay? Basically, the lowest value wins the arbitration. The control unit that loses arbitration stops sending and continues reading. It isn't dead. It's just, it's going to stop sending, but it's still active. It's reading, okay? So when the bus is idle again, the loser retries to send its message. And this happens so fast, But again, I put in there, wow, talk about a potential traffic jam and accidents waiting to happen. Think about it as a highway's going up and down. And below, I have a simple graphic of a data sending sequence. Node 1 checks if bus is available, sends data. Node 2 accepts data, checks the data, receives. Node 3, receives the data, checks the data, but it's like, uh-oh, I don't need it. It's going to ignore the data, So here's another to put it together a little bit. I don't want to get too complicated here, okay? But just make sure we're not blocking that, okay? This is standard CAN frame, Okay, I tried to keep it in a box format, a little bit easier. Okay, in cars, you see over here near the identifier over there where it says 11. Okay? That's typically used in cars. The J1939 uses an extended, what they call a 29-bit identifier. Okay, and that's the difference between cars CAN 20A. The heavier stuff CAN 20B. Okay? Where might you need to use this? If you're gonna do recording of a CAN bus data for diagnostics, if you're into data logging, looking for trends and so on, this information is useful for you, okay? In heavy-duty fleets, say we keep saying the J1939, from trucks, buses, tractors, you can use it in fleet management to reduce costs or improve safety. Your data logging, you're looking at the information. And there are files by various manufacturers, logging tool companies, that have downloadable files that can decode the raw data that you're going to get and then analyze that data in a CAN software tool that does support these files. So, I'm not going to go through the whole thing, but again, you see over the control, and I listed, it's on your handout, contains identifier, okay? You already know, this is where I said need to go back to the other slide, dominant 0. Control also contains a 4-bit data length code. Data contains data bytes. This includes CAN signals that can extract. Then you got your redundancy checked. ACK indicates if the node has acknowledged and received the data correctly. And of course, you're done looking at the frame. End of frame. Okay. Classical CAN data field carries between 0 and 64 bits, and I put in there, and it kind of sometimes we lose track of it. What is it? Okay, a bit is short for binary digits. It's the smallest unit. Okay, value 0 or 1. We already went through that. Byte is a unit information made of bits. 8 bytes is 1 byte. So. And this is, I don't have time to get into lab scope. Gino, by the way, okay, that one up here, okay, I talked with Gino, I think it was at the end of last multiplex. He said, hey, I'll send you a Pico lab scope picture over here. So I want to thank you because that is a really nice, it's kind of a clear picture, and that's the thing I always look for, something clear. So Gino, thank you so much, okay. And of course, the graphics on the side are from Pico Technology and basically on a lab scope, graphic form, it's basically looking at messages, okay? And this one here, I put together what to look for on a CAN wave. Again, I don't have time to do a lab scope thing here, but you can see over here, CAN H, CAN low, mirror each other. I even put the numbers in, 2.5 volts, each has a 1 volt peak to peak. CAN low switches from 2.5 down to 1.5 and so on, okay? But, just an example, a typical CAN bus can reject noise superimposed on 2 signals within reason. So if you get comfortable with this stuff, noise is an issue. It can cause the receivers to be overloaded, and you get to a point you're going to have loss of data. This is why sources of noise need to be eliminated first, so you don't have them, so you're not looking at. So looking at the graphic, if you add the 2 signals together, then this is another kind of little tip here. The sum should be a constant 5 volts on both signals at the same time. How do we get that? Remember that word recessive state. Both signals are 2.5 volts, therefore 2.5 plus 2.5. Guess what? In an active state, there's your 5. In active state, CAN high is 3.5, CAN low is 1.5, 3.5 and 1.5 is what? It's 5, right? So, but where I'm leading to also is this, guys, okay? CAN errors, and that can happen. As good as CAN is, errors do occur. Some reasons for errors: faulty cables, wiring, incorrect termination, noise, controllers malfunctioning, not to mention adding aftermarket nodes, okay? Error handling, what is it? Means of identifying, rejecting erroneous messages by enabling a sender to retransmit a message. disconnect the CAN node that keeps transmitting errors. So basically, you're going to disconnect the CAN node that keeps transmitting erroneous messages. Life has to go on. We're not going to shut the whole system down. Error handling is part of the CAN standard and built into every CAN controller. So it's part of it, okay? So I'll box myself back out of there. Simplified, I try to do as simple as I can. You've got CAN node, transmits a message on the CAN bus, reads every bit. Now you know what a bit is, it sends. Okay? And the read part is very important because it reads every bit that was sent. It discovers one bit that was sent dominant, but however was read recessive 1. Okay, look at the previous slides. This we call a bit error, and now node 1 raises the active error flag to let other nodes know. So note, again, node 1 does this by sending a sequence of 6 dominant bits on the bus. Then you can reread it. The other nodes see the 6 dominant bits as a bit stuffing error, okay? And I have down there what is bit stuffing. A technique inserts extra bits into a data stream to help ensure proper data transmission. Also helps to keep the receiver synchronized by breaking up long sequence 1s or 2s. And again, using 3 nodes, okay, node 2 and 3 simultaneously raise an active error flag response. This sequence of raised error flags will compromise part of CAN error. Code node 1, the transmitter, increases the transmit error code, okay, TC by 8. CAN node 2 and 3 increase the receiver error code. CAN node will automatically retransmit the message, now succeeds. Because of this, node 1 reduces TEC by 1, node 2 and 3. And again, you're going to have to reread it, okay? Because that's just an example, okay, that you need to kind of like, if you get into data logging, that stuff is really important, okay? And the reason it's built in, okay, it's used to help reduce, hopefully eliminate erroneous messages, allow CAN nodes to retry the transmission of erroneous messages. So if you're data logging, you might want to look for all this. Man, this keeps on having some issues here. Man, I'm constantly bit stuffing and stuff, you know. The benefits are that short disturbances, noises will not result in lost, invalid data. So there's benefits to this sequence, okay. By being able to resend the message and winning the arbitration, message will be successfully sent. But what happens if the errors are due to systematic malfunctions in the transmitting node? An endless loop of the sending and destroying of the same message can trigger jamming of the CAN bus. And that's why you want to maybe get into data logging, okay? And again, little continuation. Controllers have a status error counters, so they can keep track of that. There's 3 possible states: error, active, default state of nodes. The node can transmit and raise active error flag when an error is detected. You might run across a word called error passive. CAN node can still transmit data, but it now raises passive error flags when it errors. And of course, ultimately, there's a bus off. The CAN node disconnects itself from the CAN bus and can no longer transmit data or raise error flags. Codes. In a practical world, we don't necessarily get this deep unless you're data logging. However, some scan tools will log a lot of communication faults that might mislead you in the diagnostic process. This I see all the time. A good example is wiper communication faults. Yet the wipers work, driver never complained. I personally ignore those type of communication faults unless they are relevant to a very hard active fault. And you can see in the previous slides that can happen, okay? You'll notice a lot of U codes, communication codes, when there's a battery charging system, especially. Why? Each module has its fault criteria relating to voltage. For that reason, some modules will go offline. Remaining modules might set codes due to missing messages from the offline ones. And that could possibly be the reason for codes with no symptoms. You can try clearing them and see if they come back. Don't forget to record, capture, write down, make sure that maybe you didn't want to clear it. Okay? And this is a perfect example. I'm going to try to hone in real fast. Okay? Inactive after treatment control. Well, hell, I got 3 of these I have active after treatment, I'm sorry. But I also have 3 inactive, and there's more of them. They're related to wipers. You know, there's a count of 50. Why am I even bothering with that, you know? So I'm just trying to make a point here. And of course, if you notice too, on that column over here, the J-Pro pretty near tells me, you know, these are my controls that were involved, you know, the bulkhead and chassis controller. Picture on right shows, and again, shows you a little better, you know, bulkhead chassis. They tend to control less critical systems. These modules, quite often, the sensors, actuators for these systems tend to be less robust than modules like the PCM, TCM, ABS, you know. So consequently, minor variations can cause codes to set, not to mention they're more prone to error codes, you know. And that's why we went through the previous slides, okay. Resets, when I have an issue with my computer, my personal one, phone and so on, what do? I shut those things down and I reboot them, and a lot of times, oh, thank God, it's came back online. Everything seems to be working. Guess what? You might wind up doing that with some of the systems you guys work with on trucks. You know, if you run across improper communication or not operating, try a reset if the scan tool supports that function. I've cleared up inoperative systems by resets on occasion, also restored module communication. It's worthwhile the first step, okay? Removing, I got a little tip, removing a module fuse if available kills power to the module, causes the module reset. Providing the modules don't have capacitors to retain any learned values, then of course you're looking in the time constraint thing here, you know, overnight stuff. Alternative, remove power from modules, shorting only at the module, remove the fuse, back probe the power circuit, ground at the module connector, make sure there's no voltage, use your DVOM of course to do that. Jumper power ground, again, you might have to relearn that or any of the modules too, so keep that in mind, okay? Absolutely important, make sure you are on the right circuit to prevent any possible damage, okay? So be careful when you do that kind of stuff. Make sure of your terminal position, make sure you are working with the correct ones, okay? And don't forget cinch use. You know, terminals, they're very fragile. Now we plucked them away, we disturbed them, it might cause another issue. Okay? So look, James, simple testing is better. Absolutely, absolutely. Okay, and some of you guys have, I can't see all the chats unfortunately. Like I said, this month everything is a little bit off here a little bit, so I'll have to fix it. But I'm just catching the tail end of everything. If there's any questions, we're pretty near done here. So you guys, you know, you don't want to let the smoke out. Oh, this is in my electrical classes. Absolutely, all day long. I mean, that's a universal saying anymore. You know, if you teach electrical and stuff, that's the first thing everybody says. Don't let the smoke out. That's our primary goal. Very good, Jim. If you guys want, again, there's the QR code. Take a snapshot of that and kind of, I'm not sure, I told you before, I haven't gone on there. I don't know what kind of questions is, but hopefully we can keep this thing going. So snap on, let Dorman know what you think. So look, I'll be honest with you again. I told you, stable in 22, I see that too. I have that, it's pricey. And it works out not just a 9-pin connector, but it works out on all those fragile connectors. It's not a cleaner. I call it more of a rejuvenator, and it definitely does work. Okay, so but anyway, in 1 hour, I tried to put 10 pounds of doodle in a 5-pound pail. It ain't gonna happen, but I'm thinking next month, I'm pretty sure I'm going to stay into multiplexing and CAN, but I'm going to get more into probably some basic diagnostics, and wiring is so important. Actually, to tell you the truth, I'm looking at that thing with the stable, and I probably might put in a whole quite a few slides just on wiring and our real world wiring, repairing them, what we're looking for, the connections, the terminals. Because when it's all said and done, guys, when you get through trying to do all your diagnostics, you're absolutely right. You're going to wind up being at the pin or terminal and wires rubbing through and everything else. So we'll see what kind of trouble we can get into. Yeah, I think I will do multiplex part 3. So I'm going to have to call it so nobody gets mad at me because we extended it in here. So hopefully you guys enjoyed this a little bit, so